So here's some more graphing examples from section 1. Let's start with a fairly easy one. You guys see if you can graph it on your own. Y equals -3 cosine x. I'm going to try it first and then we'll check it together. And sometimes they'll actually tell you an interval that they want you to graph on. Like for example, this one for some reason I have a note by it that says graph it in the interval from -2 pi to +2 pi. But the graph paper I provided only goes to -pi to +2 pi. So if you want to use the paper I gave you, then just go with it. And don't worry about exactly where they tell you to graph it. Do you have a sketch? Okay, cool. So last time at the end of class and beyond, we were learning about graphing cosine. So cosine normally would go through the pi halves intervals are where the intercepts are, right? And then it would go up and down between -1 and +1, something like that is what cosine graph looks like. That would just be y equals cosine x, correct? And it's an even function because if we fold it down the middle, it's the same on both sides, stuff like that. Anyway, okay, so what we're doing right now is figuring out what this -3 does to it. Flips it upside down, good. What else? Makes the amplitude 3 instead of 1. Now notice how I said that the amplitude is 3, not -3, because the amplitude is a distance. That's the distance from the middle. So half of the distance from top to bottom, or you could think of that also as the distance from the middle up and down, right? So if the middle is here, then instead of going to a +1 and a -1, it's going to be 3. And because of the negative, this will flip upside down instead. What happens to our intercepts? Are they going to stay the same place? Yes, they are, because you don't stretch 0. 0 stays. If you multiply 0 times 3, you still get 0. So the intercepts stay at the same place. It's just the minimums and maximums that'll stretch to 3 times the length. Okay, did that one go okay? The hard ones are the phase shifts. So on your assignment you would have had some phase shifts. Let's start with a really interesting phase shift. Let's do y equals the sine of, okay, I have to think through it really fast, x plus, oh, and I don't want to use, see how some of the graphs I labeled with pi's and some of them I just put numbers? That's so that you had a variety of graphs to use. Because of that, though, I'm going to skip this one and just go with the one with the pi's on it. Okay, so y equals sine x. If I do a plus, that shifts to the left, correct? So plus pi halves. Okay, so our normal sine graph looks like this. It's this odd function that goes through. The x-intercepts are all at intervals of pi. It goes up and down between -1 and +1, etc. Okay, so what does this phase shift do to that graph? It's going to move all of these significant points. Remember we called them the key points? Move them all to the left, a distance of pi halves. So basically I would take those 5 key points and move them one at a time. Why is my phone ringing and why is my volume on? That's what I want to know. Okay. Anyway, she knows I teach school. What is she calling me about? It's weird. Alright. So, dun dun dun. Forgive me for that. So we're shifting those 5 key points to the left pi halves, correct? So we have a point here at 0, and I'm going to move that one to the left pi halves over here. And I have a point here at 1, so I'm going to move that to the left pi halves. And have a point here at pi, so So I'm going to move that to the left pi halves, and a point here at 3 pi halves, move that left, and a point here at 2 pi, move that one left. So the result is this graph. Does anyone recognize that graph? Bryce, louder, sorry. Okay, well, sure. But does anyone recognize this as a specific graph that we recently learned? Okay, sine is the one in pencil. Cosine is the one in pencil. Look at the one in the blue. Isn't it just cosine? Isn't that really weird? If you phase shift a cosine graph, you get a sine graph, and vice versa if you phase shift it correctly. So that means that any graph, any of these graphs can be written, every single one of them can be written as sine. Like if you have cosine graphs and you don't want them to be cosine, you can just shift them and make them sine instead, if you really wanted to. Anyway. Yeah, so doing a pi halves. Now what angle is pi halves again? 90. So doing a 90-degree shift in a sine or a cosine graph, depending on which direction you go, can lead to the other one. So this is actually an identity we're going to learn at some point, that no matter what the angle is, if you add pi halves to it, the sine of that is the same as the cosine of the original angle. It's just going to be this weird coincidental thing. Okay, let's do a harder one. I'm going to try and trick you. I didn't really talk about these last time. Try this one. Y equals cosine x minus pi fourths. Maybe I should just start with that much. Should we start with that? Okay, and then we'll make it more and more complicated. So everybody try graphing that, and then we'll just keep making it more complicated. We'll include other things to make it a little crazier. Meanwhile, I'm going to listen to my voicemail because that's really weird. I'm concerned that she would call me during the day. Alright, so let's check it together. Are you ready to check it together? Now, are you noticing with all of these graphs that I kind of like to start with the original every time? Because otherwise I start getting confused. So I always kind of just lightly sketch in the original graph. If you want to use markers, highlighters, color pencils, something to help you figure out what your final answer is, that might not be a bad idea. Okay, so this one is what kind of shift? Yes. What direction, how far? To the right, pi fourths. So that's just going to be a little teeny, well, if this is pi halves, pi fourths is half of that, correct? So we're just going to shift that point to there, and that point to there, and that point to there. See how I'm still just kind of shifting my 5 key points? That usually makes it, and you can do more than that if you've drawn more than that. But anyway, so that point will go to there. And then you can sketch it in and see how the wave has just moved over a little bit, right? Okay, let's make it a little bit harder. Let's add a vertical shift to that. Let's do the same exact phase shift, but now let's add a vertical shift. So I don't know if I talked much about vertical shifts last time, but it should be something you're already familiar with other functions. A vertical shift is just going to change where the middle of the graph is. So instead of going along the x-axis, the whole thing will be shifted up 2. So that instead of the range being between -1 and +1, if we shift that entire thing up 2, what will the range be for that graph? 1 to 3. Good. Go for that for me. So typically what I would do when I'm doing something like this is graph it in steps. So there's the cosine graph. And then I would move all of those points over and shift it to do the phase shift, right? So there's the phase shift. And then I would do the vertical shift. So that entire thing, all of those key points are moved up 2. So there's a key point moved up 2, there's a key point moved up 2, key point moved up 2, that one I went too low. Key point moved up 2. So now we have 2 different shifts going on. We have a phase shift to the right, and we also have a vertical shift upward. So that our range has changed. Is the domain changing on any of these problems? Domain is always all real numbers. So on sines and cosines. Okay, let's add one more complication to this. What if we change the amplitude so that I don't know, maybe I'll change it even more. I'll actually do a different shift. So if we put a 2 there, what does that do? Doubles the amplitude, right? And then I'm going to do a shift the other direction just for fun. I'm going to do a -1. So what would that -1 do? Down 1. Should I change the phase shift just for fun too, or not? Nah, let's leave that. See what you can do with it. So generally, you know how I usually start out graphing it before I do the moves and whatever that's happening to it? I would usually include the amplitude in that first drawing before I move it. So since this one has an amplitude of 2, my original cosine graph, generally when I would draw it, I would actually do that amplitude change with my original drawing. So, oh, that's too far. So you can see we've got our graph twice as tall from -2 to +2. Then we can shift that over and then shift it downward. Still, if it starts getting confusing, I kind of started doing it without doing the 5 key points. But I caution you not to do that probably. You probably want to stick to your key points because the more transformations in your problem, the trickier it's going to be to keep your transformation accurate. So then to move this whole thing down 1, we want to know where those key points are so that it's easy to move them down 1. Now often when you're doing these on an assignment, they will actually ask you to name those key points, which can actually be a little tricky if you've shifted them all over the place. Should we dare try to name these key points? So this key point was originally at -π12 and we moved it to the right. Actually, should we stay within 0 to 2π instead for our key points? Would that be easier, or is it okay if I'm going back here a little bit? Do you care? I'm not going to care. Okay. So this one that moved right π4 and then down 1, it used to be at -π12. So now where is it located? -π4, -1. Okay. This point would have started at 0, 2, but we moved that to the right π4, so instead of 0, it's π4. And then we move that down 1, so instead of 2, it's 1. So that key point right there would be π4, 1. this key point right here would have started at pi halves, but we moved it to the right pi fourths. Okay, that one's a little tricky. What's pi halves plus pi fourths? 3 pi fourths. Okay, so that point right there is going to be at 3 pi fourths, and then it's also down 1. Okay, now we have a point down here, a minimum point. Where would that point have moved to? First of all, it would have started, that point would have started at pi. I'm losing track of where. Okay, so my original graph that minimum would be at pi, but then we shift that pi fourths to the right and down 1. So it would have been at pi negative 2. So instead we add pi fourths to pi. So what's that going to be? 5 pi fourths? And then down, instead of at negative 2, it moves down 1 from there, so at negative 3. Okay, then we have this key point, which was an intercept, but it's moved right pi fourths and down 1. So instead of 3 pi halves, where's that one going to be? 3 pi halves is 6 pi fourths, so add another pi fourths, so 7 pi fourths. Right? Am I losing you? And that one is at negative 1, because it would have been at 0 as an x-intercept, but we shifted it down 1. And 1, 2, 3, 4, 5, that's technically 5 points right there. However, this one was kind of on that side of it. That's probably okay, but generally when they say the 5 key points, they would probably want the next one instead. So the next one would have been at 2 pi, comma 2. But we move it right pi fourths and down 1. So that puts our new point at 2 plus pi fourths, so 9 pi fourths. And then instead of at 2, it's moved down 1, so that would be at 1. So there's your 5 key points that you would list to show that you know exactly where that graph is. Because I know some of you are neater at drawing your graphs than others. So even if your handwriting's maybe a little messier and your graph, I can't tell exactly where all those key points are, if you can list them for me, then I know you know what you're doing. Does that make sense? Okay. Do we feel good about those examples? Okay, I'm assuming that none of you finished the assignment just because we didn't really finish notes.
I